Hello and welcome in this new video. Recently I've posted a couple pictures on Facebook about some stuff I've been using on ETHOS on my new radio, and I got a lot of questions, like private messages on Facebook, on YouTube and everything. So I decided I'm going to do a short like kind of introduction video, overview video of the ETHOS system, how I've been using it on my wheel loader. And one of my goals back then was trying to learn the system because I'm coming from OpenTX, HTX, been using that system for years, and I just switched to ETHOS like really recently. So the first thing I wanted to try is try some different stuffs, different things. I wanted to know if it's possible to use the same kind of tricks that I was using on HTX to ETHOS. For example, the slow up, slow down function, which is very useful to simulate inertia, for example. Also, I wanted to try to have like some kind of funny, fancy, display because the screen is really beautiful on this transmitter, the Tandem XE transmitter. And I wanted to have some kind of visual aids and stuff like that. So in this video, it's just me playing around with like logical switches, Lua scripts and stuff like that. So I made this video a week ago, but I was kind of sick. So you will hear my voice. I'm sorry about that, friends. I'm talking with my nose and everything. And the display, the screen is not that great, but I hope you're gonna find something interesting for you. And if you have any question, like precise question, just ask me in the comment section of the video and I'll try to answer the best I can.
So welcome in this new video where I will be explaining my ETHOS setup for my HITACHI wheel loader. So first of all, as with OpenTX or HTX, there is many different ways to go to a certain point to achieve the results with this kind of system. So this is just me trying to figure it out. I'm pretty new to ETHOS, and one of the things I was really trying to do was trying to train myself with this system. Bear with me, there might be some easier, maybe quickest way to implement what I was trying to do, and if it's the case, please tell me in the comment section what you would do or what you have done, etc. This is always a pleasure to learn from others on the ETHOS system. So first of all, I'm trying to simulate the real model as close as possible. So I have been using my radio to simulate 3 different speeds. I'm also using this radio to simulate momentum or inertia for the driving system. And also a couple of things, like for example, when I'm in sweep mode, the sweep mode is when I'm using the sweeper. When I use the sweeper, I want the sweeper to move in only one direction, which is to put the debris away from the loader. I don't want the debris to go in my loader. I just want to cancel the movement of the sweeper when I move backwards. And in this loader, the electric quick coupler has end switches when you unlock it. But when you lock it, well, it has kind of an integrated system. But since I fried a couple N20s motors, I was just trying to find a solution with the radio. And one of the solutions, the one I'm using now, is like I'm using like a timer to lock the quick coupler for a certain amount of time, which is 5 seconds. So let me try to explain how I did that on my radio. So first of all, the output of this model, I'm using 2x8R for 16 channels because I'm using actually 14 channels with this model. So the outputs are exactly the way physically the channels are plugged into the receivers. Physical channel 2 on the receiver is the steering ESC, the arm on 3, bucket on 4, etc., up to 16 channel, but I'm only using 14 of them. So this is very important. I named every channel output because it's a lot easier for me than when I'm doing my mixing to understand what I'm doing. So I do recommend that you name all the outputs first. This will save you a lot of headache maybe later. So let me show you the flight modes and you will understand what I'm doing. So flight mode 1 is the slow, medium, fast, and then I got the sweeper speed, which is a special speed. I want to use flight modes because it's super simple, super easy to set up with flight modes. We're going to go to the mixes, and let me show you an example for the first speed, so the slow speed. So first of all, it's only working on the flight mode 1, which is the slow flight mode, right? The source is the joystick, the left joystick, the throttle, because that's the one axis I'm using for moving forward and backward. Okay, this is the source. Then on this source I use two actions, and as you can see I'm using curves in order to simulate the forward movement and the backward movement, the reverse speed. Okay, I'll show you the curves exactly in a second. And I'm also using what we call the slow action. This is to simulate the inertia or momentum, which means in order for the speed to go to full 100%, it's going to take 0.9 seconds. And same to go from full speed to full stop is going to take 0.9 seconds. So it's just me trying to replicate the real model. Keep in mind, I'm also using a very special ESC for my driving motors. It's called a Hobbywing 1080. So this is a very good ESC that I'm using on most of my trucks and most of my models, because it's very easy to set up, and you can do some very good programmation, like you configure like inertia, momentum, speed up, speed down, the way it reacts to the terrain, to the ground. So I do highly recommend that you use this kind of ESC. And if you look on the curve over here, for each one of them, you know, it's a different curve. So let me go now to the curve. So this is a slow one, okay? This is a custom curve, 5 points. I smooth it out, but it's up to you. You don't want to use easy mode. You have to set up the thing yourself. And what you can see over here is like the maximum forward speed is going to be 60% of the total speed available. And the maximum reverse speed is going to be 75%, which explains that the first speed is pretty slow in forward, and it's a little bit faster in reverse. If I look at the medium curve, it's the same, just the numbers changes. 80% forward speed, 85% reverse speed. Same for the fast. Fast is 100% forward speed and 90% backward speed. And also you get the one which is the sweeper one. The sweeper one is super slow on forward, because you need to be very slow in order to move all the debris. So it's 40% forward speed and 80% reverse speed, because I still want to be able to move back myself pretty quickly. And like I said, you just need to apply them to your mixes, and you're good to go. Now, if I want to talk about what I did with the quick coupler, so what I was saying is I do a unlock and a lock function. So this starts with logical switches. So for the quick coupler, I get 2 of them. And look over here. So it's red for now because the logical switch this logical switch is not active. Okay. What I'm saying is this: S11 is the one I'm using for locking and unlocking the quick coupler. Okay, so what I'm saying is that the source, which is S11, should be equal to 100%. Remember, in ETHOS system, 100% is the stick down, minus 100% is the stick up. Sounds weird to me, but that's maybe me. So I'm saying that for this to be alive, S11 has to be in the down position. Okay, I press the S11 down, it's alive. So this is an unlock function. Okay, now what we are really interested is the lock function, because the lock function has a special feature, which is it will have to be on for 5 seconds, not more. What I'm saying is this: in order to lock the quick coupler, the source S11 has to be in the down position, minus 100, for 5 seconds. And look over here. After 5 seconds, it's going to stop. Right? After 5 seconds, the locking function, the locking mechanism stops. Okay, I can unlock, I can lock, but after 5 seconds, this thing stops. So if I go to the mixes, I'm going to implement this functionality for the lock system. I'm saying this is available in all flight modes. What I'm saying is the source is the logical switch quick coupler lock. That's the one we just set up. We're saying that the source equal 100% and output to channel 11, which is the channel where the ESC for the quick coupler is connected. Okay, so very easy. On the hub, I don't know if you see over here, look over here, this is down, this is not working, this is not locking, and move up position, this is locking for a few seconds, and then it stops, revert back to 0. Okay, same thing for the unlock, except that it's going to be, the source is going to be the other one, the logical switch, which is called unlock. And like it's when it's a down position, it's alive, it's active, and this one has no limit, no time limit. So because there's a limit switch integrated on the quick coupler for the unlocking function, and same it applies to the channel 11 output. Now the other thing we can talk is about the sweep mode. The sweep mode is about the fact that the sweeper just moves in one direction, and when I reverse, when I back up with my loader, it stops working. So in order to do that, I've set up a couple logical switches. First one is the one, it's kind of tricky, but as usual, look over here, it's red. As soon as I back up, I move my stick, my left joystick back, it's alive. The function of this logical switch is the source, which is the left joy, is alive when the value is below, or I should say is under, sorry, -3%. I choose -3 because if I do a 0 or -1, there's a small, you know, there's a small movement, and sometimes it gets in the way, it jams the thing a little bit. So -3 is a good value. So I'm saying that this logical switch is active as soon as I back up. Okay, that's what it is doing. Now I got the other logical switch, which is kind of nice. Now I'm saying that when I back up, this is green, right? So this logical switch is alive. When I back up, it stops. When I back up, it stops. It stops this function. And this is what I'm going to use when I'm going to say, as soon as I back up, the sweeper stops rolling. Okay? And you will have to understand this in the mixes section. It's a very simple mixes, but there's, you know, logical, it's using logical switch, so that's the tricky part. So first of all, as you can see, this mixes is alive, is on when I'm using flight mode 1, 2, and 4. So not number 3, because number 3 is the faster speed, and I don't use it when I do a sweeping anyway. So the source is S4. I just want to use this switch in one position, the down position, to start my rotor, the sweeper. Sorry. So what I'm doing is I'm applying a curve, which is a positive curve, just to make sure that the roller only sweep in one way, in one direction. So this is a curve I made, which is called positive. It's an easy curve because you can create it like in the curve section. Sorry, you can just create it. It's the pre-made curve. It's just a curve. You say function x superior to 0. Okay, that's the positive. So it's some kind of pre-made kind of curve, and that's the one I'm using for these mixes. All right, back to the sweeper. So I'm saying, first of all, I apply this positive curve, and then because I want the sweeper to start slowly and build up the speed and build up momentum, I'm using also what they call the action, which is a slow action, same as for the driving motors. This one I'm using 1 second, 1 second. That's the way you will see the sweeper starts rolling. It takes 1 second, 1 full seconds to go to 100% speed, and 1 second to go down from 100% to 0, to slow down, sorry. And of course, I apply this output to the channel 9, which is the channel where the ESC that is moving the sweeper, the ESC that controls the motors of the sweeper, is connected to my receiver. So that's going to be the first channel on my second receiver, channel 9. But wait, the trick is over here. I'm setting an active condition where I'm saying that it's only alive when I'm not backing up. See, as soon as I back up on the throttle, things stop. This mixes stop. So let me show you. I start the rotor, but as soon as I back up, it stops working, okay? Because of this active condition. If I want to stop the rotor, I just move the S4 switch to the middle position, and if I move it on the top positions, as I don't want the sweeper to move the debris in my loader, because I'm using this positive curve only, it's only moving in one way, one direction.
And for this configuration, I'm going to use a couple scripts I downloaded from this website. So all the scripts are downloaded from RC groups. That's a lot of resources. Very nice, very well made. And then you get all the scripts. I mean, not all the scripts, but some of the scripts that are available focused here. I will put all the links in the description of this video. Once you download the script you want, I'm going to show you the one we're going to use today, or this one, the one which is called status. So you unzip all the scripts you want to use. Okay, so let's for example, let's take this one. You unzip, you copy, and you paste on the script on your radio. Okay, on the script folder on your radio, you copy and you paste over it. So then you see I got the status over here. This is another status, and this is a status for the flight modes. All right, when you've done this, you don't need the computer again. Okay, so we're going to switch to the radio now. So you just need to eject drives. Wait a second. Okay, driver gone. We're going to unplug the radio now.
So now let me show you how I can display all that stuff on the screen. Very easy. I remember we downloaded and extracted, and we moved the Lua scripts from one place, from my computer to the radio. So now it's going to be super simple. For all these ones, 1, 2, 3, and the sweep mode, I'm using the Lua script, which is called Lua status. Let me show you. So for the widget, you call the Lua status. The source, for example, for the slow speed is going to be this button, flight mode 4, okay? And you can tell what text you want to be displayed when it's active, and what text you want to see when it's inactive, with which kind of background colors. You know, that's how it's made. When it's active, it's black on green. When it's not active, it's black on gray, grayish. You get the idea. And it's the same for the second gear. If I look at the second gear, it's just a change of colors. You know, it's active. When it's active, it's this background, and when it's inactive, it's the same background as all the other ones. Okay, so that's the way you do it. And it's the same for the sweep mode. Sweep mode is the same, except that you're going to choose the flight mode 1. See, you just change the color, you choose the active and inactive text, and that's it. And same for the quick coupler. Look, quick coupler, just configure the widget, but instead of trying to find for one of the flight mode button, you just say the source is going to be your logical switch that you just created, and then you just have to set up the active text parameter and the inactive text parameter, and then the color code, and you're done. Basically, you're done. The last thing I want to show you is how I did this. The timer for the 5 seconds that starts when the S11 button is in the up position. So it's a timer I created, call it quick coupler. The mode is up, so it goes from 0 to infinite. The active condition, the start condition is important, is the S11 switch in the up position. You know, that's the trick. And then the reset when the S11 button is in the middle position. So that's it. And then it's just like a widget. You configure the widget. You say it's going to be a value. Which value? Well, the timer you just created. See? That's how you display it. It's going to start. Actually, I can probably do a better version where it stops, you know, after 5 seconds. But you know, I just wanted to make sure it was working. And the other thing is, like, this is my battery running time, but I have no model connected right now, so it's not running. Since I have a LiPo sensor on my model, I can have all the telemetry for the LiPo, for the battery. Percentage, this is like, let me show you. You created, this is telemetry, and you created what we call a LiPo percent. A LiPo percent is right here. The formula is percent. You name it whatever you want. Unit is percent. You don't need any decimal for that. The range is 0 to 100%, and then you're going to say, okay, which sensor? You get the information from the LiPo sensor, okay? And the LiPo sensor is the one I got from my LiPo sensor that is on board. This is plugged to my bottle. And the range is from 1080 to 1240. I'm choosing 1080 because this is my kind of minimum, really minimum battery voltage I want to have in my 3S battery. And that's it. That's the way you can have this kind of extra information. So thank you for watching this video. I hope it was useful for you. You know, I'm still in the learning process. I'm just playing around, trying to figure out how this ETHOS systems works. So you can configure things in different ways. So if you got some other stuff you want to share, or if you have some ideas to make it simpler, for example, or more efficient, just let me know in the comment section. And if you have questions, just feel free to ask in the comment section of this video. Thank you for watching. Please consider giving the thumbs up or maybe subscribe to the channel. And see you soon.